particle in medium has zero displacement from its equilibrium position at 0.12 second intervals. So if we drew this particle going through a sine wave oscillation like that, then the time period must be two of these intervals, so 0.24 seconds. The wavelength of the wave is greater than 10 meters. 2 points are 5 meters apart along the direction of travel of the wave, and the phase difference between the particles at the 2 points at the same instant is pi/3 radians. So if now we did a displacement against position graph, get something like this, and then drawing a similar sine wave, pick one particle here, one particle here, and their actual separation is 5 meters. But in terms of a phase separation, this would be pi/3 radians. So, what is the speed of the wave? Well, we've got the time period, so we just need to work out the wavelength. And they've given us that 5 meters of gap is equivalent to pi/3 radians. Like here. So, if you notice, pi/3 is a sixth of a whole cycle. So if we just multiply both by 6, we could get 30 meters equals 2 pi radians. So a whole cycle, which is one wavelength, is here. So how do we get the speed? We just do wavelength over time, because speed is distance over time. So we just have v equals d/t. It travels 30 meters during one cycle, which takes 0.24 seconds. Multiplying everything by 100, we get 3,000 over 24, cancelling out a factor of 3, get 8, and then 1,000 over 8 is 125 meters per second. So the answer is E. Now, this was a slightly shorthand way of doing it, but the typical way that I'm sure most students will have done it is using the phase difference 2 pi times 5 over lambda, which is the phase difference, and then that will be equivalent to pi/3, and then solving for the wavelength. But here, because I knew pi/3 was a simple factor of 2 pi, or a sixth of 2 pi, I could just multiply by 6 to get the wavelength. So yeah, the answer is 125 meters per second is the speed of the wave.